I want to talk about a few ideas that I've been discussing in detail on the forums lately about sharpening. I'm going to give some links in the description to some threads where these are discussed in a lot more detail, have a lot more measurements and pictures. This is mainly going to give some background information on some topics. And the first one is an idea which is probably so controversial that most people won't even listen to it because it seems too extreme. Unfortunately, it's true. Many people have the idea that when you take a water stone like this, the reason why it cuts so much faster than an oil stone, like this, which has the same grit, they're both around 300 grit, is that the water stone generates a slurry, and that slurry is necessary for the water stone to cut effectively. And in fact, most people will argue that the slurry is actually what's doing the cutting and makes the cutting happen much faster. The actual idea is that slurries slow down cutting. That's the reality of it. Slurries are what's called three-body abrasion because you have the thing that you're trying to cut, say a knife, you have the abrasive that you're trying to cut it with, the stone, and then you have the extra body, which is that slurry that sort of rides and rolls in between the knife and the stone. Now, why does that slow it down? Well, it's kind of easy to think about it. Imagine if you were taking a knife and you're trying to cut into a piece of rope. Well, imagine that when a knife cuts into the piece of rope, the knife moves backward. So you don't actually hold on to the knife very tight. You just barely hold on to it. In that case, it's very difficult to cut anything with it. I obviously can't cut my finger because it just moves the knife out of the way. Of course, if I hold the knife in fixed position, I can't do that, and I'll cut the top of my finger off. So similarly, when an abrasive is free to move on the stone, it's just as likely to move out of the way of the steel rather than cut into it, so it slows down the cutting. So that's the raw reality. Slurries don't make a stone cut faster, they actually slow it down. That's the truth of the matter. And again, I've posted up some links in the discussion forum where this is actually studied. I mean, this is well known in industry. I mean, grinding technology is obviously not a small issue. But of course, you now have to explain the observation. But why do people think the opposite? I mean, you don't want to go all mental and retreat to it, some vast conspiracy of people trying to... Let's not be too crazy. The observation is actually true. What most people experience is when they put a slurry on the stone, it actually makes the stone cut faster. Now the action is, why then? If slurries themselves slow down abrasion, why does putting a slurry on it make the stone cut faster? Here's why. If I asked you to think about how this belt would actually cut compared to a fresh belt, what are you likely to say? You can see that it's heavily loaded, clogged with debris, and it's also worn down. It's actually relatively smooth if you were to feel it. Well, you would say, well, obviously it's not going to cut very well. It's loaded, and the grit is worn down. Here's an oil stone, which similarly has been used in fairly crazy ways, never maintained, so you can see it's heavily loaded. This is obviously not going to cut very well. Here's an oil stone that isn't as obvious what's wrong with it. The stone surface is relatively clean, but it was never conditioned in a long time, so the surface is actually really smooth. Even though this is a rather coarse stone, it's been completely smoothed out and planed over. All the grit is worn smooth, so it has very low cutting ability. With water stones, what way are they normally designed? Well, they're designed so that the abrasive is constantly released from the surface. So as it wears down, it gets released and fresh abrasive. So generally when people are comparing water stones to oil stones, and they're saying that the water stone cuts much faster than the oil stone, they're not comparing water versus oil, they're comparing a clean surface with fresh abrasive to a worn surface with clogged abrasive. If you actually take an oil stone of similar grit, use it with oil, you will actually find that when the surface is freshly conditioned on the oil stone, it will actually cut significantly faster than the water stone of similar grit, because this is pure two-body abrasion where it's only the abrasive and the edge of the knife Nothing moving, rolling around, so you get maximum cutting ability. When you switch to the waterstone, you get the abrasive coming off, it's moving, it's dislodging, it's rolling around. The cutting ability is far more reduced. So that's a rather controversial idea in some sharpening and knife circles, but in industry and in the literature, it's not controversial, it's just fact. So that's one of the things, but why do people not see it? Easy. Everyone knows you have to work on waterstones. After you finish sharpening with them, you usually have some kind of conditioning stone. This is the one that comes with Suihiro Ryu, which is this stone. It's two-sided. One is very coarse and one is much finer. So if you get a visible hollow in the stone, you can use the coarse stone to grind it down. If it's just a little bit, you can use the fine stone, fine side. And you can even use the fine side after you've used the coarse side to make sure it's not too rough, if you want to do that. But no one talks about it with oil stones. Have you ever seen people talk about using conditioning stones on oil stones? You don't need to flatten them because they wear so slowly they almost never go out of flat, but this is constant maintenance with water stones, so they're always cutting with fresh grit. But the reality is, if you just condition your oil stones, and you don't need to do it very often, I mean, I conditioned this one somewhere between 5,000 and 10,000 passes, depending on how much steel I put on it and how much force I'm putting on it, and a bunch of other things. And it doesn't take very long here, around 30 seconds, because again, it doesn't go out of flat, you're just conditioning the very top of the surface, very similar to how you recut a water stone, but it's actually much faster. So that's the first thing. And the difference in speed is actually quite dramatic. One of the things I demonstrated recently was I took a chisel, and when I restore old chisels, in order to get rid of the chips that are in the very apex, often which extend right up to the bevel, I put on this extra grind, and I just normally refer to this as a transition bevel because it's coming off rather shortly. And this transition bevel can be put on quite easily with the Suihiro Ryu. It cuts fast enough for that. But then what I need to do is take this bevel right here and then blend it back in to get rid of this transition bevel, because this transition bevel is usually 45 degrees, relatively high, and chisels are somewhere between 20 and 35 degrees depending on what wood you're cutting and the skill of the person and the steel and a bunch of other things. Trying to do that on the Ryu was ineffective. Switching over to the Norton and using oil, this is the exact same procedure done on another chisel, fully blended the face back in a very short period of time. And again, the exact numbers and details and everything around the form. This one has a slight nick left in it. Again, these are hard use chisels, so I normally don't take every bit of damage out of them because they're going to get damaged again. You see, this one doesn't even have a handle, so it's really, really rough use. So that was the first thing I want to talk about, how slurries actually affect stones and why you need to condition oil stones. Even though you might not need to flatten them, you still need to condition them. The other thing I wanted to talk about is the way I've been sharpening lately, which was done mainly as an experiment, because Chung made an offhand comment about something he called making a plateau knife. So I'm going to call this Plateau Sharpening. This knife would not be called very sharp by most standards. Little slice newsprint, sort of okay. But you can see it sort of snags the newsprint. It leaves some, little fibers coming up, and it won't push cut it at all. Not going to do it. Okay. Why am I using this as an example? I've only ground the edge on this. There's no apex bevel. And when I ground the edge, I stopped it before it actually formed an apex. That's why I call it plateau sharpening, because it leaves a light plateau on the very apex. Now, why would you want to do that? Well, what I found is that when you overgrind, when you sharpen so that you actually form a burr, well, what you do is you create a weakened strip of metal right along the very apex of the edge. And then you do have to do all kinds of little techniques and jazzes to get rid of that. And a lot of people just take it and draw it through a piece of wood and smash it back into the edge, and then you have to start over the sharpening again. I normally cut it off on the stone. And a while ago I switched to using very muddy stones, and muddy stones will sort of cut it off much better, and you don't have to do any burr minimization steps. But very recently, what I've been experimenting with is stopping it just before that actual apex is formed. So, as always, you take the knife, cut it into the stone to start off, That sort of puts a light flat on the edge, and then you grind until that flat is just gone. You just catch it just after it's gone, and then it's in the perfect position to form an apex on. There's no burr, there's no damaged steel, there's not even any wasted material from the knife. The knife has not been reduced in width at all during sharpening. So it's ideal. And the great thing is now, this knife is actually strong enough to do and sharp enough to do a lot of cutting, even with that slight flat on the edge. It won't cut tomatoes very well, it'll sort of slip on the side. But for rougher work, this edge actually works kind of nice. If you're like digging or cutting carpet, that type of deal, that little flat on the edge makes it much stronger. So that's one advantage of doing this way. The other advantage though is I normally keep all my knives like this and I put them away like this, and then when I take them out when I want to use them, they're in the perfect condition for me to put an apex or micro bevel on at whatever grit that I want. So I can take this now and with say 5 to 10 passes per side, I can jump right up to even a Spyderco fine stone or a medium extra fine DMT 6 micron stone and set a micro bevel on, and this will be literally so sharp it will catch hair above the skin. So that's kind of, I've shifted now almost to exclusively plateau sharpening. Again, I wouldn't recommend it as a way to get into sharpening. Some people have tried it and found it very easy and very natural. I sort of moved towards it. So, but I would say, I would think that it's probably the optimal way to approach sharpening because it doesn't overgrind, it doesn't waste any material, and when you get the hang of it, it becomes very simple because there's no burr formation, there's no burr minimization, and there's no multiple grits required. You can jump right from a 300 grit stone to literally a 4,000 grit stone in one big jump because you're only having to remove the scratches. You're from the very apex. That's it. You're only forming a very apex on steel, which is probably somewhere around 5 microns or so thick. You're not having to remove a burr, you're not having to remove over damaged steel, you're not having to polish the scratches out of the edge bevel, so you can make these huge jumps in grits. The other thing that's very nice about it is because you're not grinding right to an apex, you can use very coarse stones and not have to worry about damaging the edge. If you generate a heavy burr with this stone, this is a 300 grit stone, or with the coarse side, the Norden, well, then you're wasting a lot of metal. You'll see a heavy burr come along the edge, and if you frequently sharpen like that, you will start wearing the knife. How dramatically you lose metal off the edge is going to depend on how aggressively you sharpen, but it's one of the reasons why people often advocate, well, no, you don't really need coarse stones, they're too wasteful. Well, in plateau-based sharpening, there is no waste, because you're never grinding right to a very apex anyway. So you can start off with a very coarse stone, which means I can actually grind this edge down somewhere between say 25 and 75 passes per side, depending on how much force I put on the stone, but that's very quick. That's only like around 30 seconds. And then put the micro bevel on, another 30 seconds. And this is a 10V blade at 64 Rockwell, easily cut by this waterstone. So again, there are advantages to this plateau-based sharpening, and there's a lot more information on it in the description. Again, would I advocate it for beginners, for people who wanted to get into sharpening? No, not really. But if you are comfortable with sharpening and you sort of want to take something to the next level or explore a new technique, this does give you a lot of flexibility and a lot of power. So it is something that you might want to look at. And the other thing, again, that I would say is, if you're one of those people who never had very good experience with waterstones, with oil stones rather, and always found that that they were cutting slow, you preferred waterstones, it's probably the fact that you weren't conditioning the oil stones. You've probably never used a properly conditioned oil stone. Most of the oil stones that you use sort of behave like this, which won't cut at all. And a properly conditioned oil stone works by pure, almost 100% two-body abrasion, so it cuts rather fast. Slurries on waterstones, sorry, don't help them cut. They slow down cutting. The only reason that a slurry actually does, in sort of indirectly, help with cutting is that it prevents the surface of the waterstone from getting loaded. So, just a few comments on sharpening. Again, lots more information in the links that I'm going to put in the description.